Have you ever wondered how our brain processes information? It's a complex and fascinating process that's been the source of inspiration for many technological advancements. Picture this. Within our minds, a vast network of neurons and synapses work tirelessly, carrying messages, decoding signals, and enabling us to think, learn, and react. The human brain, in all its complexity, is our very own biological supercomputer. But what if we could replicate its processes, its learning capabilities, its adaptability in a machine? Well, that's precisely what deep learning aims to do. Deep learning is a subset of machine learning, and it's designed to mimic the neural networks of our brain. It's about creating artificial neurons and synapses and training them to process and interpret data just like our brains do. So essentially, we're teaching machines to learn, to adapt, to evolve. Just as our brain processes information, computers can be trained to interpret data through a concept known as deep learning. Deep learning mimics the human brain's structure using what we call neural networks. Think of these networks as a digital version of our brain's neural structure. They're made up of layers upon layers of artificial neurons or nodes, each capable of processing information and transmitting it to the next layer. In essence, these artificial neurons are like the brain's nerve cells, and the connections between them are like synapses, the biological structures that allow neurons to pass signals to other neurons. This intricate web of connections allows the neural network to learn from the data it processes, much like how our brains learn from the information we take in through our senses. But unlike the human brain, which has around 100 billion neurons, a neural network can have as many or as few neurons as it needs to perform a specific task. These networks, like our brains, are complex and interconnected structures. Each neural network is made up of layers. Imagine a multi-tiered cake, each tier with its own distinct flavor and purpose. Similarly, a neural network has layers of nodes or neurons that process and interpret the data they receive. The first layer, known as the input layer, receives raw data, akin to how our senses pick up stimuli from the environment. This data is then passed on to the subsequent hidden layers. These hidden layers are the heart of the network where the magic happens. They crunch the numbers, identify patterns, and make sense of the data. Finally, we have the output layer, the grand finale. This is where the final result emerges, based on the processing and understanding achieved by the earlier layers. These layers work together, each contributing to the overall processing and understanding of the data. It's a beautiful symphony of nodes and connections, all working in harmony to give us the power of deep learning. So, how do these networks learn? Well, just like a child learning to speak by listening to conversations around them, neural networks learn by ingesting data. This data acts as the fuel that powers their learning process. Imagine pouring a stream of words and images into the network. These could be anything from photos of cats to reviews of the latest movie. As this data flows in, each node in the various layers of the network gets to work. They analyze, interpret, and begin to understand patterns within this data. Slowly but surely, they start to recognize what a cat looks like, or what words might indicate a positive movie review. The beauty of this process is that these networks are not limited to understanding only what they've been explicitly taught. They can generalize, adapt, and apply their learning to new, unseen data. It's a continuous cycle of learning and improving. By feeding these networks massive amounts of data, like images or text, they begin to learn. And what happens when the network learns? Just as a student absorbs knowledge from textbooks, a neural network absorbs information from the data it's fed. But this isn't a one-time process. It's a continuous cycle of learning and adjusting. As the network processes more data, it discovers patterns and starts making connections. It's like piecing together a complex jigsaw puzzle. Each piece of data is like a puzzle piece, and as the network processes more pieces, the bigger picture starts to form. But what if the picture isn't quite right? What if the network makes a mistake? Well, that's where the magic of deep learning comes in. The network doesn't just learn from its successes, but also from its mistakes. It adjusts its parameters based on these mistakes, fine-tuning its understanding and improving its accuracy. The process is not dissimilar to how we learn. We make mistakes, we learn, we adjust. Just like humans, these networks learn, adjust, and improve their accuracy over time. Where do we see this technology in action? You may be surprised to learn that deep learning is all around us, subtly enhancing our daily lives. When you unlock your smartphone with your face, deep learning algorithms are at work, effectively distinguishing your unique features. As you ask your voice assistant to play your favorite song or set a reminder, deep learning helps it understand and respond to your commands. Then there's the world of entertainment, where deep learning is transforming how we play and interact with games, enabling computer opponents to learn, adapt, and provide more challenging gameplay. In the medical field, deep learning is being used to analyze complex medical images, aiding in early detection and diagnosis of diseases. These are just a few instances among countless others, where deep learning is making its impact felt. This technology powers many innovations, from recognizing faces to understanding our spoken words and even beating humans at complex games. But it's not all smooth sailing. These networks need training. You see, deep learning isn't just about creating a neural network and letting it loose on data. It's a process, a journey, if you will. The neural networks must be trained, much like a student in school, to understand and interpret the data accurately. This training involves adjusting the network's internal parameters, fine-tuning it to achieve optimal performance. It's an iterative process, a cycle of learning, adjusting, and improving. Each round of training takes the network one step closer to its desired accuracy. And just like a student, the more it learns, the better it gets. This training is critical because the accuracy of a deep learning model is paramount. An inaccurate model is, quite frankly, not very useful. So we train and we tweak, and we do it all over again until we get it right. But like teaching a child, these networks need training to get better and make accurate predictions. Despite its potential, deep learning isn't without its challenges. The journey towards harnessing the full power of deep learning is riddled with hurdles. One of the most significant challenges is the need for vast amounts of data. These networks need to be trained with enormous data sets to become efficient and accurate. Another challenge lies in understanding the decisions made by these networks. Often, it's difficult to discern the reasoning behind the outputs. This black box nature can pose problems, particularly when used in sensitive areas like healthcare or security. However, the future prospects of deep learning are bright, and they far outweigh its challenges. Researchers are tirelessly working to improve these networks, making them more transparent and less dependent on large data sets. The potential of deep learning to revolutionize industries from healthcare to entertainment is vast. It's an exciting field full of potential and promise. Though deep learning holds immense promise, it's not without challenges. Yet its potential to revolutionize industries makes it a field of great excitement and research. Deep learning is more than just a buzzword. It's a revolutionary technology that's changing the way we interact with the world and making our lives easier in countless ways. This powerful tool, inspired by the human brain, is capable of processing vast amounts of data, learning from it, and improving its accuracy over time. We've seen how deep learning uses neural networks, intricate systems of interconnected nodes, much like our brain's neurons, to interpret and understand data. These networks are composed of layers upon layers, each one processing and passing on information to the next. By feeding these networks with massive amounts of data, they can learn, adapt, and improve, just as we do. Deep learning is already in action, powering innovations that were once the stuff of science fiction. It's behind the facial recognition technology in our smartphones, the voice assistants that help us organize our lives, and even the algorithms that can outplay humans at complex games. However, like teaching a child, these neural networks need training to get better. They need to be fed with the right data and given the correct guidance to make accurate predictions and decisions. It's a process that requires time, effort, and resources, but the results are worth it. Despite the challenges, the potential of deep learning is immense. It's a field that holds great excitement and research interest, promising to revolutionize industries and change the way we live, work, and play. From your smartphone's camera to life-saving medical diagnoses, deep learning is shaping our present and future. But the journey is far from over. As we continue to explore and understand this technology, who knows what incredible innovations we might uncover. So, let's dive deeper, learn more, and be part of the revolution. After all, the future of deep learning is not just in the hands of scientists and researchers, it's in ours too. From your smartphone's camera to life-saving medical diagnoses, deep learning is shaping our present and future. Dive deeper, learn more, and be part of the revolution.